So that's what we can see here. And I just selected a random profile up here. And then what we can see is exactly where this memory was originally allocated. That's what these stacks are telling us. And memory that hasn't been freed yet. So this is how we can then understand, okay, in this case, it appears the majority of memory was actually allocated through recovering from our write-ahead log. That actually tells me, and this is true, that we probably did deploy somewhat recently, because it means that we replayed a lot of prior state, which tends to happen when we deploy or just restart our storage nodes. And as a matter of fact, I think the deploy must have gone out maybe.
And what does the width mean here?
Here you can see it's the amount of memory that's being held, or that was originally allocated that hasn't been freed.
Interesting. Okay, so 81% of the memory that the process was using at this point in time was in that function.
By this function and all its children, right? So everything in here, and something that's interesting to see here, because there's a pretty large gap between this and the children. That means that this function in particular actually is truly the one that allocated a lot of this memory.
And that other memory, that must be the extra one that it has just in case it's needed for something else, right? Because it's like not all of it is used by its children.
Let's look at these. Let's look at these numbers, right? So this child and all its children allocated 10.25 gigabytes, right? That haven't been freed, whereas this one allocated itself and all its children 18.18 gigabytes, right? And so that means that there's this one as well, but it's relatively small. So vaguely speaking, this function itself allocated about 8 gigabytes that haven't been freed.
I see.
So it's truly this function that did that.
This is very useful. This is Go. Are other languages supported?
Funny that you, of all things, mentioned Rust. So the docs that we just looked at, as of less than 24 hours ago, are actually outdated now, because we just yesterday released a library together with the folks from Materialize that allows you to do heap profiling with Rust if you happen to use the JEMalloc allocator.
Well, very timely. Very, very timely. Cool. So this is memory. Is there also I/O?
Yeah. So that would have to be
Part of blocking.
would have to be part of blocking, basically. But there's something interesting about our CPU profiler, which is sometimes when you're writing user space code, most of us probably only write user space code, we observe it, then we basically, when we do a syscall, let's say a read syscall, right? Because that's I/O. We can't really tell which part of that ends up being just the kernel doing genuinely work versus the kernel actually also just waiting for I/O to happen, with some network device or something like that, right? And so what's really interesting about the CPU profiler that we have, and I can maybe try to let me do this. Now we're focusing it only on this particular pod, right? And now I'm pulling up only CPU profiling data only for this pod. So let me see if I can find something over here, for example. We can see also the kernel stacks. And so this is really, really interesting, because now we can kind of, again, with fact, say this was actually work that is genuinely being done on the CPU, just in kernel space. Typically, if we don't have a profiler that gives us this kind of data, we would just see this blocking, right? And we wouldn't know, is this actually a CPU thing that's happening right now? Are we waiting for the network controller to actually receive something?
Okay.
So this is actually really important that you have data like this.
Cool. And is there anything special that needs to happen for this data to be available? Like any configuration, anything like that?
If you're using the Parca agent to collect CPU profiling data, all of this comes automatically out of box. You don't need to do anything.
If you enjoyed this, there is a podcast that goes with it. Check out pod.gerhard.io. For the full conversation, go to makeitwork.gerhard.io. Until next time.